Part 2: Classical Vision. Long before neural networks existed, engineers crossed the semantic gap by hand with clever mathematical filters. These old ideas are not obsolete, they are the bedrock that everything modern is built on. So let's roll up our sleeves and see how they actually work. The most basic operation in all of vision is the filter. A filter takes an image and transforms its numbers to reveal something useful. Some filters are simple and work one pixel at a time. To make an image brighter, just add a fixed value to every pixel. Watch the numbers on the grid climb together. To increase contrast, push the bright pixels brighter and the dark pixels darker, pulling them apart. But the truly interesting filters do something different. They look at a pixel's neighborhood, not just the pixel itself. Take blur. To blur a pixel, you replace it with the average of the pixels immediately around it. Do that for every pixel and sharp edges soften. Now, why would anyone want a blurry image? Because blur removes noise, those tiny random speckles a camera sensor adds in low light. Averaging a neighborhood cancels the random flecks while keeping the real shapes. And here is the insight that this whole course turns on. This one little move, slide a small window across the image and combine each neighborhood into a new value, is the single most important idea in computer vision. It has a formal name, convolution. And it is so important that it deserves a chapter entirely to itself.